My name is Seshu. I'm from GE Digital. Uh, for those of you who don't know GE, I will give a quick 2 minutes introduction to GE. So, GE is the biggest manufacturing conglomerate. We serve healthcare, transportation, aviation, power, various other verticals as well. So, GE Digital is a new BU that's formed 3 years back. The goal of GE Digital was basically to consolidate all the IT efforts within GE and also uh, to go after the digital market. That's the industrial IoT market. So in that regard, we started building a platform called Predix. It's predix.io for more information on that. So the idea there is to we GE has about 3,000 plus customers, partners, suppliers. This is the biggest ecosystem in the manufacturing. So we sell anywhere from getting deals. Every 2 minutes, there is a flight that takes off that has the engine. And also, we sell a lot of equipment in healthcare industry. A lot of MRI scans, devices. There are a lot of devices in the scanning and diagnostics equipment that we sell to hospitals. That's a lot of healthcare business out there. Power, we have nuclear power plants, uh, oil and gas, um, with gas turbines, power plants. Um, Power is the biggest industry in our area, biggest vertical in our area. When you have a lot of these verticals, each one is doing their own little things. We want to consolidate all the digitizing the data and provide analytics in the consistent way so that we can see outcomes in each of those verticals. That will be a valuable for you as well as it's value for our customers as well. So there is a bigger problem here. I'm specifically going to talk about the DevOps side of things. He has 310,000 employees, and out of which about 45,000 are connected to either their right code or their operations infrastructure. Uh, that's a good amount of people we are talking about, right? So a lot of times they do their own things. They run their own servers, their own ATMs and things like that. Very fragmented and isolated. So when we come to G digital, um, forward. Let me introduce myself. So you need to contact me. So when you talk about this, how do we cater this? How do we build a platform that can cater all of these? Because we don't want to do in silos, right? So these are the four pillars. We these are our goals, right? One is developer productivity. So a lot of microservices being developed, legacy applications. Many microservices last couple of years in particular, in the G digital, we started building microservice architecture. So developer productivity is key. They don't want to spend time on figuring out how to do CI/CD. They want to write the code and let the system take care of it. So we are going more towards the serverless build architecture. So they don't need to worry about what Jenkins or any other systems for that matter. They should be able to control all that code. They might have them in their consoles. Time to release. It's important for us. The more faster we release the software, that's better for our customers. Software quality. So we can't jeopardize the quality when we ship it outside. Obviously, we're talking about the outlines and very mission critical applications. Uh, those have certain requirements that we need to meet. That means we need to go hard on software quality. How do we bring those things? How will common developer know all these tools? How do we, there are at least the 30 tools that are out there. It's practically impossible for developers to know all these depth and breadth of these tools. And the last one is cost optimization, right? Every business unit is spending money on these things. We want to centralize all of that. So these are the four pillars for us to do the investment and build a centralized platform. So the challenge is obviously limited capacity. This is our data center. 3 years back, we took a floor and we built a data center that has, a couple of racks and put about 60 to 100 VMware cluster to basically to get started on the Jenkins and other tools and all. We quickly ran out of it, right? We quickly ran out of capacity. We don't have power out there. If somebody hits the pole outside, that's gone. So this is not how we run the IIoT platform, right? So then we decided to build this platform in a cloud-native fashion. We went on shopping, right? So this is our shopping list. AWS. We tried a couple of other things, but there are certain things that we wanted. One is scale and reliability and life cycle of the containers when we go to the containers. We don't want to do those things. We want some software to do that for us. So we chose Mesos and Marathon on DCOS. Docker Enterprise. The way we see this is all the development is going to shift into containers. All the builds, even your build stages, are going to shift into Docker containers. Your applications are going to be Dockerized applications. Totally, you're talking about building these Docker containers in a robust way, in a seamless way, so that they don't need to worry about how to deploy these containers. What is the life cycle of these containers? I deploy a microservice. Do I care about how it is running? No. As a developer, I don't, right? The system should take care of these things. So these orchestrations, this is where we choose Marathon and Mesos. Distributed storage. We were running an OpenStack cluster within GE. GlusterFS is 60% used in the open source community. For our use case for Jenkins and SonarQube, this fits well. So we decided to go with the GlusterFS. We have a 6-node GlusterFS storage out there where all the Jenkins home directories are mounted in there. Monitoring Nagios, Prometheus, and a bunch of other tools. And the other thing is we build the platform in Golang. So we chose all our microservices and APIs to be developed in Golang. So high level, this is what we put together. On the bottom of the stack, you have AWS, and then we put DCOS on top of that. This is where you have Mesos and Marathon stock running. You have 3 segment groups here. One is the microservices for our own platform, and you have workloads. In this case, Jenkins and SonarQube currently. We started putting scanning tools workload as well on Mesos. And all of these tasks are running as Docker containers, right? So, and then on top of that, the orchestrator. So we want this to be a self-service. When a developer comes in, they want to interact. They want to go to a single unified dashboard. From there, their experience trickle down. We don't want them to go to 12 different tools, 12 different UIs to figure out what is what. So we want to surface up that information. So for that, we started building CLIs and dashboards, API gateways so that it has extensibility, and then we build the microservices, instance orchestrators, and for metrics, system-level metrics for administrators. We are using Grafana and Prometheus. User-level metrics, we are going to surface. That will be in Elasticsearch. So the idea there is to create that unique experience. And we have some legacy tools on the bottom right-hand side. These are legacy tools that are running in the GE data centers. They have connectivity, and they send some of the workloads there to execute Kubernetes scans and things like that. So that's a high level what we have. Let me quickly show the Propel dashboard. So me as a developer, I just go in here and log in with my GE login. So we have the notion of workspace, right? So how do I do this? Just share the screen.
working mode for the presentation. Can you just flip
Just
back?
escape.
Yeah. Escape?
Yeah, and switch back.
Yeah.
All right. So this is a dashboard. So all the developers goes here. Developers, DevOps. As you can see, the owner of the workspace, suppose if you are a service line, this is the project charter. Let me go to our own team, Propel team, engineering team, right? So this is all homegrown. So these are all the folks who make this happen. I want to give a kudos to them, all of them. So the idea here is that we want to have this single experience of owner DevOps, who is doing DevOps, who is doing developers and approvers. And then you have repositories and services. Services is where you can, on the fly, instantiate a Jenkins or a SonarQube or sign up for another service. These will orchestrate through Mesos and Marathon and spin up my Jenkins instance within minutes so that I can go and access that. So right, so this typically brings our own team Jenkins. Obviously, you know, this is we didn't customize much here within Jenkins because people know how to use Jenkins. But we enforce the standards of pipelines. So writing pipelines as a code, a single pipeline for the entire stream, right? If you are in the develop branch, some of these steps will be skipped. If you are in the master branch, we are on the two-branch strategy. So the idea is that you are going to write a single pipeline for your entire thing. It is not like you write jobs upstream or downstream. We strongly discourage people to write the jobs, go towards the pipeline as a code. Eventually, under the hoods, whether it's Jenkins or tomorrow some serverless build services, you really don't care about that. So you write your YAML, and it's going to execute all of that. So the idea of, and then we interface with some of the tools for security. It's going to take a few minutes. So it's important that we need to see who is doing what are their vulnerabilities. For example, one of our surveys, these are the, if you violate any licenses, it'll show up here, or if you have any common CVEs, as a developer, I can go here and see if there are any high vulnerabilities. I can just click on that one and see the description of the vulnerability. So the idea is to centralize this experience. They don't have to go and interact with different tools. Mesos is Mesos and Marathon is under the hoods. So if you look at on the back, this is our DCOS production cluster. So we have about 32 nodes, each 8 CPUs. We're growing so fast. This happened in the last 4 or 5 months. We expect this cluster to go to anywhere from 150 to 200 nodes in the next year. So this is where all of our services are running. Inside that, our own microservices are there, as well as the user-level instances are there. These are all the user-level instances. Either it is SonarQube or Jenkins. It's been working pretty good. I'll talk a little bit about stability of Mesos and the Marathon, right? So when we were doing this, I was a little skeptical, can this sustain the load? What will be the operational issues that I'm going to run into, right? So Mesos beautifully scaled. I mean, we almost went live last October. Since then, we do all the rolling upgrades, no downtime. Our site has not been down as of now. So pretty reliable. We set up the Grafana so that we constantly monitor these. We have cAdvisor installed on all the nodes. So cAdvisor is a Google package that streams the data out of the Docker container. Prometheus can take that, and we put Grafana on top of that to mine the metrics So these metrics are in the real time. We set up the dashboards. We are currently running about 254 Jenkins, about 120 Sonar cubes. The middle ones are the slave jobs, so they go up and down. If you go and spin up an instance, if you run a job, these will go up. Right now, it's not a peak traffic at 8 o'clock in the night, so usually that goes to about 100 during the day, concurrent. In terms of the growth, our number of pipelines per day, as you can see this graph, the green one and yellow one are our legacy, the ones that are in the data centers. You can see them going down and propel. The blue line is going up. If you look at our growth in the last year, this is where we are. So still a lot of people in GE don't know about this platform. We are reaching them out, or they are not ready. So we don't even have 5% of the GE traffic on this cluster. So we're doing 4,000 builds. So this is a bigger scale problem to solve, right? So we are ahead of the game with Mesos and Marathon. What else I have? How much time we have? So going back to the slide deck. Yeah, lessons learned. Obviously, I covered service discovery. Service discovery, we use Marathon LB. It works. I wish it could be better. We do some internal traffic with level 4 LBs. Job scheduler, Mesos is great. No problems at all. Marathon, no problems at all. We wanted to run our workloads in the Docker engines, right? So we build our own, we maintain our own Docker engines on every Mesos slave. We use Mesos Docker framework to orchestrate to Docker. But the management of Docker, we do it ourselves. And the distributed storage is GlusterFS. We are using Jenkins Mesos plugin to orchestrate the jobs. We had to do some tuning in terms of understanding that plugin, but plugin works great. So we have Marathon applications that manages the persistent applications, your Jenkins master and SonarQube. And your slave jobs are orchestrated through Jenkins Mesos plugin. Basically, it orchestrates a Mesos job directly. One of the things that we did is Docker in Docker, because we don't want to have static installations or people do installations. So we introduced this Docker in Docker container. This is one of the contributions in Mesosphere. So it's a DIN container. We took that and we did some customizations on top of that. So what it gives you is, it gives you an isolated Docker in Docker. When you run your job pipeline, it starts a Docker in Docker. Inside that, there is a Docker engine running for you. And you can pull any image from dockerhub.com, or you bake your own image. So what goes into inside this green is customer-owned build slave. So that's a Docker in Docker slave. So this gives a full ability for developers to bake their own Docker containers, or they can use any of the any Docker images that are available on the Docker Hub. That just gives the flexibility for them to do whatever they want up to 6 gig. They can we let these containers go up to 6 gig, right? So because we want it to be highly performant. The downside of that is there are some data analytics use cases who want to use this. These guys presented in the previous slide. This is tied to the DevOps. So when I'm giving a 7 gig container, there are people who want to run machine learning jobs on top of Propel. We're kind of holding them back because we want to create a separate group for them and create get C5s, high performance nodes, because they usually run for an hour or 2 hours. But we have these use cases coming up, just what was mentioned in the previous presentation, right? So there is synergy going on here. So hopefully we are going to bring some of those use cases later in this year. I think we covered the monitoring. That's all I have. Any questions?
You said the Kubernetes run is run on your local setup, not on the cloud.
Yeah. Kubernetes we have running on on-prem data centers. We have 10 Kubernetes clusters. We didn't move that yet, but eventually we are going to move that into Mesos or Kubernetes. Maybe we are trying Kubernetes as well.
How are you handling your unique secrets management for your data scientists?
Yeah. So how are we handling the workloads for the data scientist use cases?
Secrets management.
Secrets management, very good, yeah. So there are two things that I wish there are out-of-the-box solutions. One is configuration management, the other is secrets management. We don't have them today. We have Vault sitting separately, but these are the two things that, at least in the open source version of DCOS, we don't have, but enterprise version of Mesosphere, you do have these solved. For our own reasons, we are on open source, so hence we need to come up with a solution that fits the bill. Currently, we are building a Vault, HashiCorp Vault. We are going to interface that with that, and we have a prototype done with AWS S3 and key store management. We have a custom way of encrypting your credentials in S3 with a key generated from Amazon KMS. So there are ways, if you are in AWS, there are ways to do that, but that requires some time and effort to do that. So we have some of those internal, depending on the customer, and their some are on AWS already, they use KMS. People who are not on KMS, then we interface with Vault and things like that.
Any of your marathon jobs doing UCR?
No, all Docker.
Any more questions? Ouch.
All right, thanks,
Thank
guys.
you.